Geologists from Columbia University discovered a large freshwater reservoir hidden beneath the ocean floor off the coast of New Jersey. It stretches along the U.S. shoreline for 350 kilometers. It's hard to tell how it appeared there. Scientists are going to drill holes in the area to examine it more closely. But what if it's a bad idea? After all, this water can have surprising or unknown properties. For example, it could prove to be a new state of matter, a superfluid liquid that no container can hold inside. Given its unique characteristics, superfluid water can leak into the tiniest cracks and pores, climb up the slopes, and cover everything it meets with a thin film. Everyone knows that water is the basis for all life on Earth, and yet it can become a threat to humankind. In this video, you'll learn under what conditions can normal water become superfluid, how will geckos save the human race from extinction, and how could we survive in a world where superfluid liquid broke free. Imagine a fishing vessel coming back to the Jersey Shore at night. The ocean looks calm, but suddenly the vessel starts sinking. There's a colossal panic on board. The crew desperately tries to do something, but all the equipment is acting up, and the laws of physics seem to be broken. All parts of the ship are getting filled with water that moves up over different objects, and finally, water creeps its way aboard. The vessel goes down. What happened here? The ship was unlucky enough to run into a flow of superfluid water. In order to create superfluid liquids like this, scientists cool helium in labs to the lambda point, an extremely low temperature of around 2.17 kelvins. In theory, you can't possibly transform water into a superfluid, as it will freeze much sooner. But if we somehow manage to shift the lambda point, water has a chance to become a superfluid, for instance, at room temperature. Just imagine, if the lambda point changes, ordinary water can become lethally dangerous. Superfluid liquid always runs away from open containers. That's because it's not viscous. Just compare. The viscosity of normal water at room temperature ranges from 1 to 1.3 millipascal seconds. In contrast, the viscosity of superfluid water is 0. That's why superfluid liquid can spread around the container walls and climb them. At the same time, they form a thin film that sweeps across the surroundings. If superfluid water broke free from its reservoir near the Jersey Shore, it would reach dry land pretty fast. Imagine this, an only around 30 nanometer thick water film slowly engulfing an entire city and getting to its residents. At first, people will feel unpleasant dampness around. Buildings, clothes, daily things, everything would start getting wet little by little. Then the water would hit the skin. It may seem okay. It is just water. How dangerous can it be? However, superfluid liquid not only coats the skin, but also penetrates it and slips inside the organism through the pores. An hour after you come into contact with this water, your fingers will look weird, as if you spent a whole day lying in the tub. Then you'll find it hard to breathe and start coughing a lot, which will indicate that the water reached your lungs. And it'll continue getting inside through the pores. When the amount of water in the body exceeds the tolerable limit, you may develop hyperhydration, a potentially fatal condition. In the very beginning, it causes nausea, swollen face and legs, and your body temperature drops. Then you'll experience pulmonary edema, cerebral edema, and disorder of water and salt metabolism. As a result, you'll go into cardiac arrest. All the city folk who were sleeping the moment the superfluid water captured them will die. And so will animals, all of them except birds. If birds don't land on contaminated waters and stay there too long, they'll be able to survive. Luckily enough, there's also an option for us to move farther inland and avoid the superfluid water, since the film won't spread across the continents in a jiffy. However, it won't be as easy as it sounds. Superfluid liquid can sneak into various mechanisms, so it just might find its way under the hood of your car. This means the vehicle will short circuit and never start. People living in coastal regions will have to rely on helicopter evacuation. That is, if the authorities bother to arrange it. I bet they'll want to stop superfluid water from spreading further inland, whatever it takes. Actually, if superfluid helium makes an escape, it'll be much easier to stop it. This element can stay superfluid only at a very low temperature of minus 270 degrees Celsius. That's why a thin film of helium will heat up too quickly, and so it'll lose its properties as a superfluid. But remember that we changed the lambda point to let water become superfluid at room temperature, so it'll be pretty challenging to control it. We can try a trick that works with normal water. Let's see if we can evaporate it. The easiest way will be to build bonfires in its path, and they really will stop the superfluid. For a while. Actually, the reservoir located off the coast of New Jersey contains more than 2,500 cubic meters of water. That's why any evaporated film will be quickly replaced by a new one. Eventually, the water will simply put out the fire. And while people are busy finding new ways to fight the superfluid, the climate on our planet will begin to change. The point is that this kind of liquid has almost infinite thermal conductivity. This means that the moment the water reaches active volcanoes, it will begin to redirect their heat all around the planet. The Earth will start getting warmer a few times faster. Glaciers will begin to melt, sea levels will rise, and the weather will change in all parts of the world. So, will people manage to stay alive? To survive in a world stuck under a film of superfluid water, we need to create a place where this water won't seep into. There are creatures able to help humans with this task, and they are geckos. These lizards can climb vertical surfaces just like superfluid water. Their feet have teeny tiny hairs covered with spatula-shaped structures from 200 to 10 nanometers in size. Thanks to these crazy feet, geckos utilize van der Waals forces while moving. This is a special interaction between molecules. The very same principle helps superfluid liquid climb the container walls. However, geckos have one weakness. Their feet are helpless when it comes to Teflon coating. But if geckos can't stick to Teflon, superfluid water will fail here as well. It looks like people need to build a hermetically sealed bunker to make it through the disaster. But it must be Teflon coated. Where can we build it if superfluid water freely spreads all around the globe? It's simple. Ambient temperature has a direct impact on how fast a film of superfluid liquid moves, so it'll reach warmer regions much faster. This means people can relocate to Antarctica or Greenland or settle at the ice-cold North Pole. Although, building Teflon-coated bunkers won't be the only problem for the survivors. Superfluid water will overlay all plants, including those we use as a source of food. Under such conditions, crops won't grow properly, so they'll go moldy and start to rot because of constant humidity. So, humans, for the rest of their days, will have to feed on the mushrooms and birds that somehow managed to survive the superfluid apocalypse.